Hey everybody, welcome. So today I'm gonna live stream NASA's system and see if I can update it on a version of my own. Uh, yeah, so I'm gonna do the furthest zoom out real quick. Here's the furthest zoom out. I'm gonna try to make it three-dimensional for everybody, even though it already is. This is the furthest zoom out. So when you go into the Qualar, you can see everything. And you get all the way to our solar system over here. Mars, Jupiter, Saturn, Uranus, Neptune, Earth, Venus, Mercury. Here's Mars. So what's cool right now is we just saw the instance of a landing, as you can tell by this little white line. As far as I know, this is also Mars Reconnaissance Orbiter. Trace Gas Orbiter, Mars Odyssey, and as far as I know, these are all SpaceX endeavors. I'd love to work for them. I'd love to start my own company as well. But here's what their orbiter looks like. So this is their antenna for either ionic propulsion, as far as I can tell, or communication through the satellite array. This is for energy, solar shield ion thrusters as well, probably all of the above. I don't know, I'm studying as of right now. Tinfoil, gold tinfoil to help with something, I don't know yet. Here's its imager. Here is the instruments. Here are the instruments, sorry. Let's go look at something else over Mars, huh? Let's look at the trace gas orbiter. Same instance, bigger thrusters and solar arrays. My thrusters for my satellite, as far as I remember launching with a permit when I was young, was jet propulsion boosters that burn in stages to an ignition of a small electric charge, and then they burn in succinct ignition. Um, so Phobos, here's its moon, which is more looks more like an asteroid than anything. Let's look at the landing site here real quick. Gonna try to update the images. So let me zoom out again. I've shown you here. I'll show you every single one of the planets that I have images of and my 3D mock-ups of their scale, size, gaseous state, heat maps, and everything of that sort. I'll then show you instances of updating the image array the best I can with images of these planets out here in the background and their mass and size and everything culminated to everything like that. Here's Juno, like Hey Juno, the movie. It was a very good movie. This one is interesting. So basically, it's rotating on a 360 rotation. I thought it was the moon. I got that wrong. Where is the moon, this planet? Let me look back at the planet. Oh, here are the moons: Europa, Ganymede, Callisto, Io. Over to Venus. Another gas giant. Time controls. Let's do the real spin rate plus 5 days. Let's get a good look at what Voyager 1 looks like. So this is Voyager 1. If I could give any input on the design of these dish arrays for the radio frequency or their frequency of communication with Earth, and especially these antenna arrays, what I've found works better is an instance of perpetuating an EMF discharge in the dish through a melting of an acid with a battery that's being melted faster than it's charging anything, as that stamp has a power input device, an instance that can charge and implant data through other instruments and the charge change into the dish, um, instead of being just a radio frequency dish. I have my instance of a few multiple radio frequency devices, um, like this Lily Ghost screen I was making something with, this hypersonic SRO4 sensor. Um, and this is my hotspot currently. I was also using it to build my own blockchain and build my own CPUs and circuits, because it's a perpetual bytecode updating circuit, and it also runs the base core circuit itself. So the baud rate is about 1120 or 80 baud rate. My instance of the satellite imagery I was showing you the other day from Google Earth and Mars comes in at a baud rate of 9600. So I'm going to zoom out again to the entire qualar or quasar. I'm trying to remember the right word. And I'm going to make this as 3D dimensional as I can. And if my satellite's gotten as far as I thought it would, or has, then we'll be able to build a more cumulative picture from just some mathematics. I'll even walk you through it. I'll be right back. All right, so I have a few equations for the algebraic find home sequence that is used in satellite and rocketry engineering and aeronautics. I have a few instances of solving it that are a little different, but have come out concurrent in void loop sims, especially for my forging of non-fungible coins for the future of the system of perpetuating not encryption but validated instances of data. As with another sequence that's a secret, as it uses A and V to solve that is known, kind of like the credit card theorem of the 18 numbers and other instances of those numbers meaning a mathematical sequence, so it's known and unknown. Um, but in algebra, we learn the find home sequence. The other find home sequence that I know is -2 plus 7, or even it might be vice versa. But if you do it on both sides of the equation and um, go in arches, vice versa, you get the appropriate symbols and syllogisms for the equation that the other find home sequences find properly. Um, I'm also working on a circuit design for instances of game handhelds, stuff like that. Um, this is the ESP 32, room 32. That's a radio frequency, wireless frequency. I'm trying to currently make a project out of it to upload a binary translation instance of ones and zeros, so I can always just write on the screen ones and zeros and see the application come up from it instantly. Um, as as everything else, let's go ahead and change the screen from the images you see here of everything in our Qualar and our solar system. Qualar quasar, I so need to get that right, correctly pronounced. Um, all of these instances um, and I just think I might have made a mistake and wasn't live streaming properly. Hold up. Excuse me. So currently I'm going to write an equation for an if else equation of if else x equals 42 or 3, and put that into the generation of the algorithmic intelligence that's generating these images concurrently with a three-dimensional reality instance of the LCD screen through the graphical user interface. So let me open up Python here. Let me switch the array of what screen it's watching. So here is Python, as you can see, in tandem with everything else. I'm reconnecting. I'm reconnected. Hey, welcome back. Welcome back, everybody. I'm reconnected. So this is the equation I'm trying to put in, and I want to see if it updates. And it says perhaps I forgot a comma. So let's see if it updates like this. No. And now let's see if it updates like, no. Let me ask my other AI real quick if how to write this equation. Excuse me. Let me plug in this equation and see what comes out as how I should write it. Excuse me. So I forgot an asterisk. Asterisks. Apparently they're called commas. If X, they also came back with an error. Oh, hold on. No, it came back with an error. So it's coming back false. Um, and let's see if we can zoom in on the supermassive black hole. This is why I'm trying to make it three-dimensional properly. Have they found Europa, the dwarf planet, or the exoplanet? I don't see it saying exoplanet up here. I can't seemingly get it to update like I did yesterday. What? I think I might have gotten it to update properly. Yeah, I just updated it properly. So if we want the center, not center, the center, the center mass, mass. Now it looks to be a little bit more in depth. So that's how brightly our sun shines throughout the entire solar system and throughout the entire galaxy, the Milky Way galaxy. Yeah. So there's an update on the design and the parameters. I only still have one soldier watching, or it's my own video feed watching itself. I have 3 requests. Or wait, hold up. Yeah, I do have requests for somebody to join the live stream, so I'm gonna get that all figured out. I'll be back tomorrow to keep working on this with everything and everybody involved. So